Hello, hello, and welcome everybody to Science. Happy Friday, etc., etc. It's great to see you. Let's get started. Outdoor Solutions, part deuces. Today, here's the things you're going to need. Science notebook, pencil, pen. If you were doing the investigation along with us and you collected your own outdoor samples, and made some mixtures of your own, great, we can use them today. If you did not and you're using the samples that we have, great. And then down here at the bottom, I can observe a scientific phenomenon. I can design an investigation to see which outdoor substances create a solution when mixed with water. So to recap, on Tuesday, we went out and we looked for different materials just out in, we used the garden here at school. You might have used your front yard or backyard or something like that, to see what kinds of materials could potentially create a solution. If you don't remember what a solution is, or what a mixture is, they are there, right? A mixture is just any two materials mixed together, right? Trail mix, Chex Mix, those, what do you call them? The snacks with like the Flamin' Hot Cheetos and the pretzels and the, all together. All mixtures, right? Solutions are a little different, right? Our big identifiers with solutions, right? One thing is dissolving into another, meaning incorporating itself fully to the point where you can't even see it anymore with the naked eye. And it cannot be filtered out. So the solute is still there once it's been run through a filter. And lo and behold, look, here we have filters here. We're going to run them through. If you are going to be following along with us at home, thank you, Jose, Munchies. That's exactly what they're called. If you're going to be following along with us at home and you're going to be doing your own filtering at home, okay? If you, let's say your grown-ups drink coffee and you've got some coffee filters, you can absolutely use those. The setup that we've got here in the science lab is we've got, there it is. We've got a coffee filter that I wetted a little bit just so it would, our mixtures would flow through a little easier. And then we've got this funnel on sticks that when we put a cup underneath, it'll drain underneath. If you don't have that at home, that's okay. If you got a funnel, great, make it work. If not, you can put your filter directly on top of your container and you just kind of hold it like that, or you could even tape it if you've got tape at home and then pour in. Let's say you don't have coffee filters because you're, family's tea drinkers, maybe. You can use a napkin or a paper towel or even like a thin-ish piece of cloth, like this cotton t-shirt actually would work pretty decently. Okay, same thing, put it over the top of our container here, and then you're gonna pour your mixture through it. Now, I would test with some plain water first, because you wanna make sure, maybe it is too thin a material and it rips, right? Then we're no longer filtering, we're just pouring something through a hole in a napkin, right? Or maybe it's too thick and the mixture won't actually drain through. It'll just kind of sit on top, right? So I would test with some plain water to be sure and see how fast or how slow we need to pour it. And you can see here, this one is draining through pretty decently. So I could use this as my filter here, okay? And in theory, as it drains through there, in theory, any unincorporated material is going to stay on the top and not go through the filter. And if it is a solution, our solute and our solvent will flow through together and stay as our solution. Okay? Behind me, we've got, there they are, we've got our 4 different materials. They're kind of glary, so let me scoot it over. There we go. We've got our grass. We've got our kale. We've got our wood. And we've got our pieces of flour. Okay, and what I've got here, just a quick and easy data table. Okay, prediction beforehand. We're going to take a look at our different mixtures and kind of make a prediction based on what we see already, if it's going to be a solution or not. Then we're going to filter it through and be able to look at the filtered water and be able to determine if, in fact, it is a solution or not. Okay, so let's begin at the top with our grass. Here is our grass here. I'll put it nice and close to the camera. What do you notice about this grass and the liquid that's in it? We're trying to see if it's made a solution by soaking. Still looks pretty clear and translucent, so maybe there is some dissolved material in there. Do we see a color change? Not really. Okay, so quick, make a prediction for yourself. Is this a solution or not? I'm going to pour this in and let it filter, and while it's filtering, we'll look at the next one. Okay, so pouring our grass solution through here. Okay, while that's filtering out, let's take a look at our kale. Here's our kale. Some definite bubbles going on at the top, which I find interesting. You see those bubbles there on top? Curious. I wonder if there's some sort of... What were the bubbles that... Do we remember what was causing the bubbles to bubble up when we were having or experimenting with yeast last trimester? What gas created those bubbles? I wonder if that gas, if you know it, put it in the chat. I wonder if that gas is actually happening here and we're getting some breakdown of our kale into sugars. Interesting. Let's see. All right, our grass has filtered out. New filter. Move our grassy solution. Maybe if it's a solution. And a new cup. And did you hear that? I don't know if it... Oh, God. Oh. Okay. Couple of things happen here where I know something's going on. One, there was a legit like a soda bottle opening. And two, it stinks. You are not here to experience this, but this smells bad. There's been some definite change going on. I don't know if it's a solution, but there's definitely some sort of change going on. And I'm really upset that I now have to pour this very close to my face and let it sit there. Ugh. 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 Okay. Just gonna... Ugh. Yikes. Ugh. Ugh. Oh, it smells so bad. Oh, there's definitely some sort of change going on in here because the smell... I'm going to put the cap back on because that smells terrible. Oy, oy, oy. Oh. Ugh. 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 While we're doing... Oh, God, I can't... My eyes are watering. Legitimately. This is not an act. It's smelly. Okay. Oh. Wood. Here's our wood.
Here's our wood solution. Gah. Definite change. I hope this one doesn't smell too. Oh my gosh.
Whew.
Yikes. The stench coming off this kale is incredible. All right. Definite changes going on to our wood mixture. Still pretty transparent. Like I can see the big kind of chunks of wood in there. So it'll be interesting to see if this created a solution or not.
Oh. Yuck. Okay. I'm going to get rid of this. Ugh. Yuck. You can see here on the, you can actually see on the filter for our, let's scoot this down. On the filter for our kale, there's some definite greenage that has been caught by the filter. So we filtered some stuff out here. Oh, yuck. Okay. Put that as far away from me as possible because that smells awful. Okay. Oh. I can't get over it, guys. I really can't get over it. Oh, that was bad. All right, wood time. Will this make a sound? No. Is there a reminder? We haven't done this in a while. Reminder on how to properly smell things in science class, right? You don't just stick your nose in front of it and sniff. That's how we burn the inside of our nostrils. Give it a waft. Okay, this is a much more pleasant smell. It smells like the forest. It smells like the forest, right? You've got all that moisture kind of at the bottom, like if you've ever been to Redwood Regional Park in Oakland, where you have these kind of dense forests and a lot of moisture just kind of stays on the ground, and the ground stays pretty moist. That's kind of what this smells like. This is much better than the kale, which was rancid. Question in the chat, should we be writing the results now? No, because you haven't seen the solutions yet. Okay. Pouring, pouring, pouring. I want to get as much of the liquid out as I can. There we go. All right. Ta-da. While that is filtering, let's go to the last one. The flour. This was a full-on flour. And bubbles as well. Maybe some more. Still nobody remembered that name of that gas that the yeast was giving off as a waste product when they were breaking things down into sugars. They could use them as food. Okay, so very cloudy. You can still see through it, but some bubbleage. Okay, make a prediction. Is this a solution or not? Let's look at our filter from our wood, and yep, we got a whole bunch of wood pulpies in there. Okay, that helped filter things out. Get rid of that. It still smells like gross rotten kale in here. Ooh. Anyway, okay. Move that one. And lastly, our flour solution. Let's give a quick waft of this one here. It's pleasant. It smells like, smells like a flower. It's not as bad. We said carbon dioxide in the chat. Ding, 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 ding. Thank you. Yes, carbon dioxide is that byproduct. It's what made the noise when we opened up the kale. And the smell is also evidence that there's some sort of like reaction or some sort of breakdown of those of the kale into sugars that's going on here. Okay, here we go. Now, while we're filtering out this last one, do some thinking for yourself of what evidence. Oh, that's a much stronger smell that came out as I poured it. It's not great, but it's not great either. It's definitely sweeter than the kale. There's definitely some sort of something breaking down here that's happening. Okay. Ooh. Did I double up on the... No, I didn't. Interesting. One thing I'm noticing, if we can zoom in on the filter here, one thing that I'm noticing is the flour, the water that had the flour soaked in it is filtering a lot slower, a lot more slowly than the other three. And I wonder about that because maybe there's some sort of viscosity thing happening. I'm going to give it a little squeeze just to help it along. Maybe it's become more viscous because of the presence of the flour. Maybe it's maybe there's something else happening here. that's making this filter a lot more slowly than the other three, which I found quite interesting. I'll give it a little squeeze here, help it along. While we're doing that, be thinking about this. What evidence are we going to see that will tell us if we've created a solution? What evidence might we see? And put that in the chat. Okay, I have officially finished filtering that out there. Gross. Put my funnel system over here. Okay, now we've got all four of our solutions. We're going to start with our grass mixture. This was water that had grass sitting in it for 3 days. Let's take a look. Is this a solution or not? I don't really see any change, do you? See, there's a little white stuff at the bottom. That's leftover wax because I did not clean this container clearly enough. Definitely no like cloudiness or solid matter because that all got filtered out. But is this, it's definitely still clear, right? Can we tell, can we definitively tell right now just by looking at it if it's a solution or not? I don't think we can because there's no visible change to me. Okay? Think about, as we look at the other three, think about how else could we test if the grass has created a solution or not. Okay? Next one, our stinky kale. It still smells. Yeah, it still smells bad. It's like spicy, which is not how kale's supposed to be. It is gross. Okay, looking down, and here is our kale solution. Thank you. Ooh, somebody's calling for a control, and I agree. Let me show you. I'm going to compare it to some plain water here. So here's our plain water, and then here's our kale. Put them side by side. Let me even move the word wall out of the way so you have more space to see. There we go. Okay, so here's plain water with nothing added, and then here's our kale water. Definitely got some, I'll even go lower here. Definitely a color change here. This one's kind of pinkish, which is curious because the kale was green. So my prediction on that back on Tuesday was that the kale might tint the water green. But in fact, it's kind of pinkish, which is interesting. Curious. Let's compare again to the grass here, because somebody was like, I can't tell because I don't see the water. Here's our grass on this side, and then here's our water. As you can see, it's still really clear, right? This one, it's much less conclusive. Whether the grass and the water, the grass has actually made a solution here. Jury's still out on the grass. Okay, let's do a quick check. Results inconclusive. Kale, I would say yes, that's a solution. There's been a definite color change. The smell is kind of a giveaway too. All right, get this kale away from me. My gosh. Ugh. Okay, next, our wood. So again, here's plain water, and then here is our wood water that has been filtered through. And as you can see, big time color change there, yeah? Big time color change on that one. What was interesting to me is if you can, it's hard to tell on video, but there's a lot less water in here. There's a lot less, the volume is a lot smaller. And I think a reason for that is because our wood samples absorbed some of that water, just like how wood will kind of puff up or bulge up when it's wet. I think that my guess is there's still a lot of that water that we put in, a lot of that 50 milliliters of water that we put in, still kind of trapped, that's been absorbed up by the wood. But our color change definitely shows us there has been a solution created. Okay. Last one. Oh, almost spilled it. That would have been a terrible mess. Last one is our flower. And as you can see again, big time color change. This one's almost the darkest of all of them. I wonder about that. I wonder what about the flower, what about the biological makeup of the flower makes the color change that big? Is it something about, the idea of flowers being really colorful and being really bright? Is there something about the pollen of the flowers that absorbed or that dissolved? A future experiment I could see is breaking down the different parts of a flower and seeing what actually caused this color difference. Right? This would kind of be an extension to that. Okay? Definite difference there. There's a blade of grass that is just has gone rogue and is in there. All right, so I got another whiff of that kale grossness. Ugh. All right, we've got yes, 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 and inconclusive. Now, one thing we could do, if we remember back to our salt and Epsom salt and citric acid solutions, those were all clear. But what we found was that we could tell they were a solution because there had been a change in mass. So if we had 50 grams of water at the start and then we weighed our solution afterwards, and it was, the citric acid I think went up to something like 87 grams or something, right? Showing that there's still a lot of that solute that had been dissolved in, right? So what we could do for this grass is weigh it, and we will attempt to see. My wonder is we might still be on an inconclusive because there wasn't that much, the grass didn't have that much mass to begin with. The grass sample that we put in was only about 1 or 2 grams. So at most, there would be 1 or 2 grams of change. Mars also says you could test its density. Absolutely. We could do some sort of experiment where maybe we add like food dye to this or something. And then we, put a sample into a beaker or a container, add some water to it and see which one ends up on the top and which one ends up on the bottom. Potentially, certainly, right? So let's see here. We've got, this is our water, so we can use it as a control. I'm going to weigh it. I'm going to tear that. So again, we had 50 grams was the weight of our water. And we're going to see what we get here. You might end up, see, we're already down to 46 grams. My guess is, because there's still 4 grams, just like with the wood, that there's some water that's been absorbed and is still in our container. So I think the problem with really definitively being able to say if this is a solution or not is small sample size. We'd have to go and get a much bigger sample in terms of mass in order to really see a difference in that regard. So actually what we're going to do is we're going to leave this as inconclusive, or we can't tell. Okay? And that's okay. Sometimes with science investigations, there isn't a conclusive result, and that's fine. All right? So we're going to leave these as is, inconclusive for the grass, yes for the other 3. Exit ticket is on Google Classroom. Go ahead and try it. There's going to be a couple of questions about this. Man, I'm still just, this kale smell is messing me up big time right now. Couple of questions about this investigation, and then it's going to give you a data table where it's going to have you take a look at some data that's been collected about 4 mystery substances, and based on the data, be able to say whether each one is a solution or not. A little challenge for you on a Friday. All right, thank you everybody for tuning in. Have a wonderful weekend, and I will see you next